This is the three-dimensional Hubble ultra-deep field. It shows the structure of the universe, which consists of galaxies and galaxy clusters. They form the filament structure, with the large empty spaces in between, the voids. In cosmology, the natural constants are precisely tuned. This fine-tuning of the universe is essential for the structure from the cosmic scale down to the subatomic scale. N is the ratio of the electromagnetic force to the gravitational force between two protons. It is about 10 to the 36. With a smaller n, there would be only a short-lived universe. With a very big n, the repulsion would be too strong. Nucleosynthesis of heavy atoms would be impossible. The proton is 1836 times heavier than the electron, which is another fine-tuned constant. Epsilon is the efficiency of the fusion from hydrogen to helium. It is 0.7%. 0.7% of the mass of the hydrogen atom is converted to energy. If it were 0.6%, a proton-neutron bond would be impossible. If epsilon were over 0.8%, almost all of the hydrogen would have been fused to heavier elements after the Big Bang. The strong nuclear force is important for epsilon. Density parameter omega is the ratio of the mass density of the universe to the critical density. Omega is near 1. With 69%, dark energy is dominant in the universe. That makes a big freeze scenario in the far future more likely than a big crunch. However, the nature of dark energy is unknown. Lambda is the cosmological constant. It is the ratio of the density of dark energy to the critical density of the universe. The value of lambda is 10 to the minus 122, and it is fine-tuned. A slightly higher cosmological constant would cause a rapid space expansion that would make the formation of stars and structures in the universe impossible. Only 5% of the universe consists of bright matter. Dark energy and dark matter dominate the universe. Q is the ratio of the gravitational energy required to tear a large galaxy apart to the energy equivalent of its mass. Q has a value of 10 to the minus 5. If Q is too small, stars can't form. If Q is too large, it would lead to a violent universe where stars could not exist. The Condor galaxy, NGC 6872, is a large barred spiral galaxy with a diameter of 717,000 light-years. It is located 212 million light-years from Earth in the constellation Pavo. D, the number of spatial dimensions in spacetime, is 3. According to British cosmologist Martin Rees, life could not exist if D were 2 or 4. If there were more than one time dimensions, physical systems would become unpredictable and intelligent life could not evolve. Under such conditions, protons and electrons would be unstable and would decay. The triple alpha process is the nucleosynthesis of carbon-12 through the fusion of 3 helium-4 nuclei. The product is carbon-12 in the Hoyle state, a nucleus in a high-energy state. Only one in 2421 nuclei goes through an internal conversion to carbon-12 in ground state. All other nuclei decay back to helium-4. The Hoyle state is fine-tuned. That makes carbon the fourth most abundant chemical element in the universe. GNOPS is an acronym for the most common chemical elements that are used for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The carbon single and double bonds are fine-tuned. They are strong enough to build the molecules of life, such as proteins and DNA. But they are not too strong, which makes it possible to recycle biomass. Carbon chauvinism is the argument that life could be based on other elements, such as silicon. The anthropic principle is an observation selection effect. We are able to observe the universe because we live in an era that allows the evolution of intelligent life. In the early universe, there were only the elements hydrogen, helium, and lithium. 100 trillion years from now, star formation by the collapse of gas and dust clouds will end. We live in the golden era of the universe. Not all scientists support the concept of the fine-tuned universe. There may be a theory of everything, a unification of relativity, gravitation, and quantum mechanics. It could explain why the constants are the way they are. The CGH cube is a three-dimensional coordinate system with the speed of light c, the gravitational constant g, and the Planck constant h as axes. M-theory unifies superstring theory with mathematical transformations called S-duality and T-duality. S-duality is a relationship of a collection of strongly interacting particles in one theory. The same particles can be viewed as a collection of weakly interacting particles in a completely different theory. T-duality, also known as target space duality, is the equivalence of two physical theories, which may be either quantum field theories or string theories. Our universe could be just one of potentially infinite universes which make the multiverse. The other universes should also have space, time, matter, energy, and information. The physical laws and constants in these universes could be identical to those in our universe, or they could be totally different. The CMB cold spot is a large region in our universe that is cooler than the typical cosmic microwave background. According to one theory, this could be the result of a collision of our universe with another one. This is a beautiful new image of the star-forming region, Digel Cloud 2S. It is located at 58,000 light-years from the center of the Milky Way at the edge of the galaxy. NASA's James Webb Space Telescope has observed young newly formed stars and jets of ejected material. Outer regions of galaxies are known to be relatively poor in elements heavier than hydrogen and helium. You can check out the links to the scientific articles in the description field. And you can check out my other videos about astronomy. Thank you for watching.